Okay, I'm probably live now. I see a few people on. Let's all say who we are. Probably live now. I see a few people on. Hold on, volume down. Let's all say who we are. Okay. Right. Today we're going to be looking at a game. I was talking about a game last week called Tower Defense, but since then I've played with a friend's game, and I got bored of it and decided I would write a program that would play the game for me, and that's what we're going to do. So I think like Bone has probably seen this. Has anyone else seen this? The 2048 game. I have a copy of it here, and there's a link in the video. There's a link in the video description to the game that I'm going to be looking at. It's this thing here in front of me here. So the idea of the game is that you want to get to 2048. Now it doesn't stop at that point, but I'm just going to demonstrate. Very good. I'm going to demonstrate how to get to 2048. So you just use your arrow keys. So whenever any two tiles, if you press down, left, up, right, all of the tiles shift in that direction as far as they can go. If any two numbers hit that are the same value, then they'll get absorbed and added to each other. Now, in the normal 2048 game, what happens, you'll have noticed here that every time I do this, a new tile appears. So in the normal 2048 game, the tile that appears is always a 2 or a 4. But in this variant, the tile that appears is always the same value as the lowest tile that exists on the board at that time. So you see 8 is the lowest value here. And if we can somehow manage to get all the 8s off the board. Now when I press down here, those two 8s are going to combine, and then the lowest tile on the board will be a 16. And now I've got a new 16 on the board. Now to get to 2048, there are a number of different variations of strategies. I normally just try and keep everything off to the corner, so you can just, like, I'm just going to press down or up and try and keep everything in the corner. So I'm just going to play this until I get to 2048, which will be very, very soon, looks like. Has anyone here played this before? And there we are, 2048. So in the normal game, what happens now is that you're told you won, but it doesn't stop you from continuing. Now, if you look up here on the right here, you can see there's a little best, which says the highest score that you can get here. I'm going to get that to infinity. I'm going to get an infinite score, but as you can imagine, it would take a while to get to that score. But what we can do is we can hack the game. You played the game, Amit. I bet you've never got to infinity though. We're going to do that today. Okay, so the first thing that we need to do is look at the source of this game to see what's going on. Because obviously when you press a key, something is happening. That means that there is something running in the background. You got to 2048. Okay. Well, I just did that there as well. So what we're going to find out is what happens when you press a key, and what can we do to inject a piece of code in there that will then handle what happens afterwards. Alright, so let's look at the source. So I'm just going to go view page source, and that opens a new tab, and it's probably very, very small. Now if we just glance through this, you got to infinity -1, okay. If we just glance through this code, we can see that's 1, 2, 3, 4. You can see that's the grid that's being displayed. Okay, so just glancing through it, you don't have to read every line of it, but you can just get a kind of a gist of what's going on in the HTML. So you got the standard header stuff, which just kind of says like, oh, it's 2048. You're linking to some styles, and then you got the header 2048, and then we have this little grid which is the items in there. Now we could write something which watches that, but we can go a bit further on down and have a look at all these. These are the scripts that are being used for this. Now, it's not how I would write something. I would normally write it with just one script or two scripts or three scripts, like just try and keep everything as close together. But whoever wrote this game wrote them all in different pieces. So we can look and find out. You can kind of guess what a lot of these do. Like the grid.js probably manages the look of the grid. Tile.js manages a tile. Now let's see. The actuator is what I edited. Now the application here, let's look at the application. It's the last one in there, so it's probably the thing that does something. So I'm just going to open that in a new tab, and you can see it just starts. Like it just basically says, when the page is ready to load, run the game manager. So let's look at the game manager. And handily there's a script there called game manager. So I'll open that in a new tab. This is more like it. So, and again, you don't need to understand all this. You just kind of have to get a kind of a gist of what is it trying to do. And handily, look at that. We've got comments. Comments that basically tell you what the code that's coming up afterwards is going to actually do. Now, so prototype setup. You can see when it sets up, it's setting up the score, blah blah blah. But right down the bottom, this is interesting. It runs something called this.actuate. That's interesting. Just keep that in mind. So set up the initial files, blah blah blah. Let's see what actuate actually does. There's actuate there. Game manager.prototype.actuate. Now this prototype thing is, if you've done Java or C# or C++, then you'll have come across the idea of objects. JavaScript is not an object-oriented language. It's a prototyping language, but they're kind of similar. They're similar-ish. The prototype, when you're creating an object in JavaScript, it is basically a prototype that you can then use. You can actually clone that object and create something that's similar to that. But it has methods that you can attach using the prototype. So this actuate here is attaching a method to the game manager object called, this one here is attaching to the game manager object a method called actuate. And that is, it's basically what happens once a move has been made. And let's have a look and see if actuate is used anywhere else. So, oh, there we are. What's that? What's that? That's after a move, it runs actuate as well. So actuate is only ever actually run twice. It's only ever used twice. One is at the start of a game when it needs to do something, and one is after a move has been made when it needs to do something. Now, I'm going to hack that. Okay, let's hack that. So in order to hack that, I'm going to hack it into the running system. We're going to do something which is called a man-in-the-middle attack. Man-in-the-middle is traditionally in hacking, like in normal hacking, a man-in-the-middle attack is where you read somebody else's input and you pass that on to where they intended to go, and then you send back what that returns as if it was the original site, and the person that put in the input doesn't know that you have that information. As an example, I did this for somebody a couple of years ago. Anyway, if you fake the Facebook webpage login page, and you send that to somebody and says, "Hey, look at this Facebook post somebody put up," and they click on that link, and they don't notice that it's not actually the Facebook page, but it's just something you made to look like the Facebook page, then it's possible that they will put in their username and password in order to log in. Now, to keep the illusion alive, what you should do then is forward that username and password onto the real Facebook page, find out what that says, and then return that and actually log the person in. But in the meantime, you are recording the email address and password, or the username and password of what they've just done. So now you know you have their details. Now that's a bit rude. There's another interesting way to do that as well, which is to set up a Wi-Fi hotspot, an open Wi-Fi hotspot, which actually fakes the DNS of stuff. So it will do the same thing, but it will actually look like Facebook. Now it doesn't work these days because pretty much every website has HTTPS at the beginning, and it's tested. So whenever you're going onto a website and it has HTTPS at the beginning, your browser is actually testing it to see, is it real? Anyway, there are ways around that as well, but it gets really technical. But we're doing something similar here, and I'll just show you why. So what I'm going to do here is I'm going to overwrite game manager.prototype. I'm going to create. Now you can see that they have an actuate here. I'm going to create a new one. Actuate old, a new function, and I'm basically attaching it into what was there already. Game manager.prototype.actuate old equals game manager.prototype.actuate. Okay. Now it doesn't do anything yet. If I just press something in here, you can see like it's just working away as normal, not really doing anything. But what I want to do now is I'm going to overwrite the real game manager.prototype.actuate. Game manager.prototype.actuate equals. Now here's where we have some fun. So I'm going to create a function. And then what I'm going to do is call the old one, which is a copy of the real one. Okay, now let's see what happens. If I press a button, I broke it. That wasn't meant to happen. That wasn't meant to happen. Why didn't that happen? Oh, right. Yes. Okay, that didn't work because of how object-oriented stuff works. It's trying to keep memories of things. So you don't actually call game.prototype.actuate old, because then you're calling the prototype of something. You want to call the actual method. It's kind of technical, but anyway, if I just do this instead, this.actuate.old, then maybe it'll work. Now I may need to start the game again. We'll see. Man in the middle. Oh, look at that. It's working away, but every time it makes a move, it's recording. That number is increasing. It's recording that you've actually done something. So, very good. Yeah, but you're still you're still very far away from infinity. Okay, so what we've done here is we've injected something which is kind of listening to it, and it's responding. It's saying like, oh, they made a move. Oh, they made a move. Oh, they made a move. Now, what we want to do is take over the moves. So I want that every time you press up or down or whatever, that it will then respond to what happens next and make another move. That's where it gets fun. Okay. Yes, you're still far from infinity, but don't give up. I'll give you a clue. It's a number in JavaScript. It's a number with about 300 zeros after it. So you need to get to that. Anything past that and JavaScript just kind of gives up and says, ah, you're at infinity. So if you add 1 to a certain number, you get to infinity. It's very large. Alright, so next we are going to, now what I'm going to do is quite large. So over on the left here, I've got my scripty thing here. So I'm just going to create a new file. and I'm going to call it 2048 solver.js. And I'm going to do basically what I did on the right here, but this lets me then copy paste from the left to the right. So I'll just copy what I've done here. Okay, and we'll make it neater so we can actually see what's going on. Okay, so the old actuator kind of tells the system, all right, it's made a move, do whatever happens next, which could involve updating the scores, adding a new tile into the screen, etc. Now, what we want to do is to make another move depending on what's on the screen. Now, there is a strategy in this game which will get you very far. You might be thinking like, let's say, right, at this point you might be thinking, well, I need to combine certain numbers. I can see there are two 40/70/96 and two 20/48s. If I combine the two 40/96s, I get a higher score. It's interesting, but it's the wrong strategy, because at that point you now have three different kinds of number on the screen. Okay, you've got the 8192, you've got the 4096, and you've got the 2048. You really want to have as few numbers on the screen as possible, different numbers, because if you have very few numbers but you've got a lot of tiles, then any move is likely to combine them and reduce the number on the screen. You ideally want as much space as possible on the screen, so you need as few different numbers as possible on the screen. That's too much. That's why we write a program that will hack it. Now, if you combine the lower numbers, because of the way this particular version of the game works, if you combine the lower numbers, then actually the lower numbers vanish. So let's do that again. So 2048 there, okay, combine them. Okay, now we've got the 40. Now the lower numbers have combined. They're quite getting large. Anyway, all right, I'm getting too excited about this. Right, here we are. Now there are only two numbers on the screen. There's a 16384 and there's the 32768. Those are the only two numbers on the screen. Everything else is a duplicate of that number. No matter what move I make, I'm going to combine something. If I move left, then I'll combine these two. If I move right, I'll also combine these two. If I move up or down, I combine these two. All right, so that's what you want. You want to have it that pretty much any move is going to combine things and reduce the number of tiles on the page. So we need to know what direction can we move. So if I move down, for example, well, yeah, and down again. Okay, now we have something interesting where there's really only left and right will actually combine things together. So we want to know that. How do we know that though? What we do is we look at the grid and we look to the right and left, well, just the right really, of each row in the grid and see are there any two tiles together which are the same. All right, so let's try that. So I'm going to check the grid. So in order to know what that is, right, we'll look back on the source again and see what's going on here. Which one is that? That. And we look through that and see what it has. And we can see it has this thing here called self.grid, for example. And this.grid. Okay. That's interesting. Let's have a look and see what that contains. So I'm going to just output that. Console.log this.grid. And I can get rid of that line, right? So I'm going to copy that now into the console to overwrite what we already had. Now let's see what it says. So I'll just clear this so we see what happens. If I hit left to combine two, then we have this object showing in here. And what is in it? Let's have a look. So it's got cells and it's got tiles. All right. Now, if you look at this and compare it to what's on the screen above, you'll see that they're not visually the same because they're not in the same orientation. But if you look, if you kind of twist things around, you can see tile, tile, null, tile is the same as tile, tile, null, tile. Alright, so we've got across is the same as down. And if we look at the next line, null, 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 tile, null, 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 tile, null, 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 null. So that means that we now have an idea of what's on the screen. We don't have to do anything magic here. We don't have to go read the actual HTML. We don't need to take screenshots and do, you know, character recognition. We don't need to do anything fancy because we have a copy of the data. We can look at just the data and see what's in there. Let's look a bit further into that. What is a tile? So the tile is the x coordinate and the y coordinate and the value. The value. That's interesting. Okay. We don't really need much more than that. In fact, we probably don't need the x and y. We just need the values. Yep, I'm just looking through the sample code I wrote earlier, and I'm only using the value. All right, let's have a look at this. So we want to know, can we go left and right, or can we go up and down to combine things together? All right, so we've got, so we'll call that the direction good. Okay, so var dir good equals 0. Okay, so we're going to say that 0 is that there is no direction will give us anything, and 1, let's have a look and see what we get. 1 will say is horizontal and 2 is vertical. Okay, so let's have a look through the grid. I'm just going to minimize this again so we can see what's in the cells, just the cells. So for var I equals 0, I is less than this dot grid dot size. Can we do size or we can do cells? Yeah, you can see here size here 4 is basically 0, 1, 2, 3, 4. We could do that, or we could count the values in cells, which is equal to 4, but I'm just going to use size here. Now, if anyone gets lost at some point, just ask a question about, like, you know, what point you got lost. Like, just tell me what's confusing you so I can just explain a bit further. I don't mind going back over this. So for var equals, I'm creating an incrementer just to count through these things because I'm going to go through each of these horizontal or vertical lines one by one and just check and see, are there any two numbers that are right next to each other? And by right next to each other, if 16384 is here and 16384 is here, I'm combining though. I'm thinking of them as right next to each other as well. So that means I also need to get rid of any, filter out any spaces. So var c equals 0. I'm going to say c is the cells, the valid cells, and they're horizontal. Don't need that yet. Okay. Now we'll check each of the cells. This dot grid dot cells dot for each. So for each of these cells, we're going to check the cell value. If the cell exists, well then we're going to push its value into C. Now C, if you see there, is our array of cells. CV I dot value. So we're pushing the cell's value into the array, basically the bag of values that we're gathering. So we're gathering a bag of values. Now, after we've got them, we're going to check them and see, are there any two numbers right next to each other which are the same? So we're going to check each of the values in C. And we've got two numbers to look at here. We've got the value itself, but we've also got the position. And you'll see why in a moment. So we want to see, is the number next to this, which would be c idx plus 1, this index plus 1. So we want to see if it exists, because if you're at the bottom of the index, if you're at the right at the end, then there is no next one. So we need to see if it exists and its value is the same as our current value, and its value is equal to the current value, then we'll say that our dear good equals 1. We'll say 1 is equal to horizontal. We're not saying right or left yet, we're just saying horizontal. Okay. So now, after all that, we should be able to say console.log dear good. And that will tell us, is there a possible left-right motion that combines things together. Okay, so I'm just going to put these into the thing now. Press enter and see what happens. If anyone gets higher than Amit in the game, you know, tell us. Let's have a bit of a competition here. I'll clear out what's in there and we'll see what happens if I press down. Okay, we've got a 1 here because these two are the same. And we're still going to have these for a short while until I combine them. And now we've got a 0 because there are no two numbers that are on the same row next to each other. Okay, if I press down, well, then you'll get a 1. Now you've got a 1 because these two are right next to each other. Okay, now what if we say that if there is a horizontal number, then it will automatically make the move? How would we do that? Well, let's look and see what the program itself says about moves. So we'll go back into the code here. And you'll see it's got this map here, up, right, left, down. So it's got moves 0, 1, 2, 3. It's going by a clock. So 0, 1, 2, 3. That's pretty common in a lot of ways. Like you find that in CSS and other ways. If you need to say that a direction has a number, then it's very common to use a clock as a guide for that. So 0, 1, 2, 3. Okay, so we'll say 0 is up, 1 is right, 2 is down, and 3 is left. So how do we tell it to make a move? Let's write a piece of code for that. It's got a thing called move here. Sorry. All right. Now, and bam. So we're going to call that that piece of code there. Wow, that cough was intense. Right. So let's see. But I'm going to put it inside. It's a kind of I'm going to give it a millisecond to do something, and then I'm going to make the move. So function. I'm going to make this function called make move. And we'll say if we have a direction. So if they're good, then we're going to make a move. This dot move, and we'll just say move 1. Sorry, we're going to move left. 0, 1, 2, 3. So we'll just move left. Okay, so if there are two next to each other, then it's always going to move left. Okay, and we'll just do a set timeout, calling make move, and we'll say it's going to call. We're going to call, actually make it 1 second. Give us time to actually see what happens. Okay, hopefully this will work. So we'll clear that and just stick that code in. Press enter. We'll see what happens. Now, if I press left. We don't have anything next to each other yet. Okay, okay. Right. Now if I press down, then that number and that number will be on the same row and they'll have the same value. So that should force a left. But what's interesting then is that they'll combine to make a 65,536, which is the same as that. And then they'll combine and make 131,72. So the bottom row should entirely combine when I press down, hopefully. Let's check it and see what happens. It broke. This move is not a function. This move is not a function. Oh, yes. All right. That again is a little piece of advanced JavaScript. This object has changed when I did that set timeout. So we need to actually record what this we mean. What does this mean? So we'll say var $this is equal to this. And then we're going to say $this here. There's this object is contextual, all right? It means that when we're talking about when this function is called, this means the object itself that called it. So when it's like if somebody hands you something and you say this is a phone, well, you're talking about the thing that you have. Now if you hand that away to somebody, you can't say this is a phone anymore because you don't have it anymore. So when we do a set timeout, what we're doing is we're actually handing the process away to something in the future, this make move. But make move doesn't know what this is anymore because it's not talking about the game manager anymore. So we need to record what this was and then pass that forward. Now luckily we have this thing called a closure, so it actually remembers this. It remembers the context, or it remembers that this this thing goes further into this. So when we're talking about this here, it will actually look further up because $this is not the same as this. That's a special code. Okay, that should work. Let's try this again. So copy all this down to here, press enter, and hopefully if I press down we should have something similar again. Down 1,000. Oh, that was cool. That was cool. Try that again. Alright. Oh, that was pretty cool. Press down again. Okay. Alright. Now let's do that again, and we'll do it for the vertical lines as well. Okay. So I'm going to put in a vertical line piece of code as well. So this one is for horizontal lines. I'm just going to put a comment at the end. Horizontal. So we know that, because looking at the code you don't know. So that's horizontal. And I'll just shrink that down because I don't need to see it anymore. Now I'm going to say vertical. So for the vertical stuff, it's a lot more complex. With the horizontal stuff, if we look at one of these grids, anyway, it works differently because you need to get at the numbers in a different way. So with the vertical stuff, this is all vertical. This is all vertical. Like that first one there, tile, is down, 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 down. So I can just look at that. So let's look at these cells here. This .grid .cells. I'm looking at each one of these cells, which is the group of tiles. I'm going to look at these in sequence and see if there are any next to each other. And if there are, well then we're going to call that a vertical move. So for each cell, now it's actually a cell group. What we want to do is actually filter out the null values. Remember what I mentioned, that like I'm just going to see if I can get one. There. All right, the third row, the third column here has 2 null entries in it. Let's look at that. So we want to filter out these and only return an array of things which has tiles in it. Now I could do similar to what I did before, where I actually go through them one by one, and if they have a value, add it in. But there's a fancier way of doing that, which is to use filter. There's a function called filter. So we can do that. So we'll say that the cell fields equals c dot filter. We're going to filter C. Let's call this D. And we're only going to return Alright, the way filter works is that it checks to see if something has a value. If the callback, which is this thing here, if that returns a value, well then it will keep the number. If it doesn't return a value, well then it will scrap the number. So in the beginning we have this array of 65,536, null, null, and 65,536. And then it's going to go through and filter them all and say the first one, do we keep that? And it returns a value. A value means yes. So yes, we'll keep that. The second one, do we keep that? It returns a null. A null is not a value. So it scraps that, scraps the null. Then it scraps the next null, and then it keeps the number after that. But they're combined to create a new array which only contains values. Alright, so CF is now a bag of values right next to each other with all the nulls taken out. And we can prove that. Console.log CF. I'm going to get rid of all the other console logs. Because I don't. Well, I'll keep this grid thing because it's interesting to look at. Okay, and this code is getting large. Right. Because the code's getting large, it's getting tricky to select everything. I need to make it smaller. Code smaller. Alright. I hope that's all still readable. Alright, let's see what happens. Okay. Alright, so here we have the values that were returned. So you can see here, tile, 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 that's this. We've got an empty array, and then we've got one tile, and we've got one tile. All the nulls are removed. All we're left with is the tiles. So we can now go through that pretty much the same as we did with the horizontals. So just shrink that down again. So now we can go through that like we did with the horizontals. And just check and see, like, is the next value equal to the current value? So we could actually, if we want, literally copy paste the code that we did before. Why did I call it CF? I'm just going to rename these. So that'll be C group, let's say CG, just so we can have that as C, which would be cells. Yeah. Okay, and that means that I can literally copy and paste this. And there we go. C to for each. Dear good. Now in this case, dear good, we want to set it to be 2, which will be a vertical number. Right. Dear good is going to mean vertical. So now we need to adjust this code. So if dear good is equal to 1, which was the horizontal, well then we make the horizontal move, horizontal left in this case. And now if dear good is equal to 2, well then it's a vertical number, and I want to move down, always down, 0, 1, 2. So that will be 2. Right, this should be fun. Because it's going to always move now if it knows that there is a valid move. It's getting quite large. Alright, so I'm not, instead of making the codes bigger or smaller each time, what I'm going to do is save the file, then cat it out, which lets me do this. Let me just go like that. Select it like that and then paste it in here. Okay. Now, let's see. So it now knows what to do if it finds a horizontal or vertical number. There's a mistake there. These two and these two are vertical numbers. They really should be seeing that. So that means we've made a mistake. So why didn't it see it? Let's look at that code again. Oh. No. Oh, yes. It's because we're not actually recording the values, we're recording the tiles. So in this case, we need that. Right. Okay, this will work this time. Okay, just clear that up and cat it again. And copy. There. Now it should know what to do. So we'll make another move to trigger it. That was a down move. Alright. That's pretty cool. But now we can see a flaw. Alright. The flaw is in the strategy, because that number there is less than that number there. We really want it to... But there's another flaw, a more important flaw here. There are 3 different numbers here. And we really want to get rid of the lowest number. So, first thing, before I get on to solving that, one thing I wanted to do is never stop. I wanted to always have a move to make. So, in the case that there is nothing, that there's no good move, I wanted to make a random move. So, let's figure that out. We'll say that horizontal is always a good move, because in this case, if I start moving up and down and left and right, then you end up with a mess of a thing. So I would say always choose horizontal. I'm looking at my code from previous, and I did choose horizontal as the first best move, but there's a better solution after that. I'll do the horizontal first, and then we'll solve that. So we'll say there's always... In fact, no, I'm not going to say that. Alright. Okay. Let's step on a bit further. We'll say that we want to find the best... Like, that's a good move, but there's a better move. There's always a better move. If a left-right move combines 2 numbers, that's a good move. But if a left-right move combines 2 numbers and they are the lowest numbers on the board, that's the better move. That's a much better move. So we want to be able to tell the difference between those. Alright, let's see. So we've got dir good, but let's make another one called dir best. Now, in order to know that something is the lowest on the board, and we need to know what is the lowest number on the board. In order to know that a combination involves the lowest numbers, we need to know what the lowest numbers is. So let's find the lowest number. So we start off with lowest equals 0, which is obviously impossible because all the numbers have numbers. All the tiles have numbers. So we'll say that for this .grid each cell. Now we're kind of cheating here because we're using some code that's in the game itself. Function x y tile. Now, what I mean by that is that I actually, if we look through the code, then you'll actually find that here. It actually goes through all the code. So I'm almost copy pasting what was written beforehand. So before you start hacking something, you really need to kind of get a gist of what is going on in the code already, so that if you need to do something, there might be something already in the code that does it. So if tile and tile.value, so if the tile exists and the tile has a value, then we want to set right. Why did I do this? I did something fancy and I really shouldn't have. The reason I did this is I wasn't actually considering that I might have to teach this. So I wrote something which is probably complex to explain, but it works well. So this is called a ternary operator. So we see if lowest has a value, then it's going to run this, and if it doesn't, then it's going to be tiled that value. So if we start off with 0, then 0 is not a value, so it's going to be this one, tile that value. So it's going to accept the value, whatever it is. So the minute it comes across a tile in the first place, it's going to say, yeah, okay, that's the lowest now. But now that we have a value, the next time it comes across a tile, it'll actually select the minimum value between the current or the new tile value. Either way, we should be able to tell now what is the lowest value on the board. So let's check that again using the same trick. Okay. Copy, paste. Okay. So lowest value on the board, 242144. Yeah, but it's going to be finding it very difficult. It doesn't know how to get. Look at that. It combined the 2 5 values, even though they weren't the lowest numbers. Doesn't know what to do. Go right. Right. So the value is getting bigger and bigger. It knows now what is the lowest number on the board. Now we need to write some code to tell it to prefer that. Okay. So let's go back into the code now. All right. So let's see. Dear good, dear good. So this is where we've realized that the horizontal. We're looking in the horizontal section here, and we're saying that yes, there is a horizontal move we can make here. So that makes it a good move. A horizontal move is a good move. But now we want to know if the value is identical with the lowest, is the same as the lowest value. Well, then we're saying that this is the best move that you can make at the moment. Okay. And then we'll look at the vertical and do the same. So we'll say that if, in this case, cv.value is equal to lowest, then we'll say that dir best equals 2. Okay. And then when making a move, we want to decide what direction are we going to do. Are we going to use the good move or the best move? So if I'm just going to say what move we're going to do. So if we're going to use dir best if it exists, otherwise we'll use dir good. Okay, so now instead of dir good, we're just using dir direction. Okay. So now it will prefer the smaller values over the larger values. I'm not going to bother running this again because it's not going to make much of a visual difference. Right. Now, if it doesn't come up with a move, we want it to make a move anyway. All right. So we want it to be kind of a random move. Oh, another thing as well. See the way this number here, 1677728, that's smaller than this. Because we're always pushing to the left or pushing down, that's never going to get any better. So we want it to kind of randomly move left or right, you know. So just kind of decide, like, what does horizontal mean? Does horizontal mean left or right? It could mean left, could mean right. Okay, so we'll just say up here that when we're starting, let's see, don't know why I put that in there. I'm going to put it down here. Alright, so we're going to take a random number. Now, in JavaScript and most other languages, when you do random on its own, it gives you a number between 0 and 1. So we want to know if it's larger than or equal to 0.5. Well, then we're going to say that the number is 1. And we're going to say that 1 is actually right, which is a horizontal number. Otherwise, we're going to say that it is 3. And 3 is left. 0, 1, 2, 3. That's a coincidence. Okay. So instead of, let's say, dear good equals 1 here, we're going to say dear good equals the horizontal number. Now we've got a visual difference, so I'm just going to run that now and see what happens. So this time, whenever it comes across if I press down here, there's a 50% chance it'll go left and a 50% chance it'll go right. It went left, down, it's still going left. Yes, alright, yeah. That's because in the code, when I'm saying what move to make, I forgot this. So 3 is 0, 1, 2, 3. 3 is always left, always left. So we now don't need to use this anymore because we know that the direction is always going to be the correct direction. 1 is right, 2 is down, 3 is left. So we'll just say this dot move in the direction. So what is the direction? Okay, 0 is up. We rarely ever want to go up. We will in a minute, but going up is kind of it's like giving up. It's like you've got no other good move to make. Okay, try that again. Oh, that's not good. Oh. But you see it's going right sometimes and left sometimes. The reason it's going up in these cases is because it literally has no other good move to make. So in some cases it has nothing else to do, so it will go up. But we want it to go... we want that if there's nothing else to do, then it'll actually try down, then left, then right, whatever. Okay, the idea of trying something and seeing if it fails or, you know, works, we need to actually code that in, because I looked through the code for this and it doesn't have a way of identifying. Now it's always trying to go up. It's always failing because there's no way of going up. The code for the game itself doesn't have a function which says whether a move is legal or not. It's always just do it, and if it worked, it worked, and it changes it. It doesn't say like this is a legal move. Okay, now you can do it. So what we need to do is try a move, and if it failed, try a different move. Okay, so let's work on that. So we want to say what are the legal moves that we can make. So we'll just add that at the end here. The legal moves, the directions that you can make, are, and this is in the order that we would prefer them to happen. So 2, which is down, left, right, up. So we wanted to try these directions one after the other. Okay, and we'll say that dir at equals 0. This is the direction that it's tried up to this and worked or failed. Okay, so make move. Now, so the direction that we're going to try, if there is a best move, then take the best move. If there's a good move, take the good move. Otherwise, we're going to use one of these directions. Okay. Now, in this case, it will choose the first because dir at is 0. So if there's no good move to make, move down. But we want it to check and see, did it work? And if it failed, try again, but with the next. Now, there's always going to be one value and one good move you can make. All right, so we need to record the current state of the board, make a move, and if the current state is exactly the same as the current state after the move, well, then it failed, and we just try it again. So current state equals JSON.stringify. So we're basically taking the object and we're writing it down into a string. And believe me, this is all worth it. You know, what do you see when this is all done? Serialize. Yeah. Now, this code is that there's actually I found a piece of code in here. That kind of does this already. It records this store manager. It records the current state of the board into the thing. So if I was to just close that or reload it, then it reloads at the same state. And that's because of that code there. It actually records the current state. We are going to take advantage of that to just have a look at the current state here. And we make the move, and then after the move, if the new current state, so we just do exactly the same again, is the same as the old current state, then we're going to increment dir at, and then just make another move. I'll just make it as soon as possible. Just do it now, as soon as possible. So it's always going to do a move now, and it will prefer to be down, left, right, whatever. Okay. I think that actually is the entire thing. You know what? I think that is the entire thing. Let's just check that for a couple of iterations and see what it does. Oops, piece of code broken. Now, it's not very smart. It doesn't tell me where. It says line 36. Oh, yeah, that's right. Okay, didn't expect it to tell me the line. Try that again. Okay. Down. This.actuateOld is not a function. Let's reload that. Okay. So sometimes when you're editing with something live, you may break the old one. So just reload it. And we'll just run that code again. And press it down. This.actuateOld is not a function. Oh, yes. Yeah. Because I've never actually done a reload in it before. Okay. Now we actually do need to reload the page. Clear it up and then run. Now it'll work. Down. Okay. Now, I believe, given time, this will get to infinity, but it's pretty slow. Let's speed that up a bit. So, in the solver, if we look down here under make move, it's running once a second. Let's speed that up a bit. Whoops, what? Come back, you. This is going to be fun. I'll get rid of the console log. So I'm reducing it down to 1 millisecond. It probably won't run at 1 millisecond, but you know, that's because JavaScript is not exactly on time all the time. Let me clear this out, and then we're going to do this fresh. Now, here's where it gets fun. So I'm just going to scroll this up a bit so we can see the high score. Oh, look at score we are. Oh, that's pretty cool. Now, what happens if I press any button? Let's say down. It's nice and fast. Look at that score. Oh no! Try again. Okay, look at that. It's got so large now that it can't be expressed with normal numbers. So it's using exponential numbers. The 34 means it's basically the number at the beginning with 34 zeros after it, or 34 digits. But you see it's getting quite large. Now there might be something I'm forgetting here. Let me just check that code again versus my own code, because mine is usually a little bit better than that. Yeah, that looks around right. Now there is a possibility that it's running the same code twice in there because of... No, I know this. Yeah, that's fine. It's fine. It's working. 130. Right. Now, I've mentioned already that the highest possible number in JavaScript is it's a number with about 300 digits after it. So this same method that I've described here, that I've shown here, is you can use that to basically hack any game. So if you've any game online that any game online that you want, that you think you know a strategy for, but you want to run it a bit quicker and just, you know, see how far you can get, then just follow what I did here. Like basically you need to find an injection point, a point where you can basically stick in a man in the middle. Oh look, we reached infinity. There we go. Alright, bored now. Okay, so any questions? Are we still here? Any questions? I'm going to run this again. Does this work in online games? This is an online game. You are online. That's a game that's online. So yes, it'll work in pretty much any game that uses JavaScript. The point of this is that it's all in one page. It's all in an incremental game. What do you mean by an incremental game? A multiplayer game. Now, I wrote this in a JavaScript game. Now, I don't, like, you're probably talking about other things like multiplayer role-playing games that are using C++ or whatever. You know, obviously it's not going to work in that because that's not JavaScript. But this works in website games. So if you have a multiplayer game which is a website-based game, then yes, you can do that. You could, for example, write grinders. Like if you... yeah, paperclips. Yeah, you could do that. Yeah. You could play paperclips with this. you just have to figure out what is your strategy. Like, what do you want to do with it? What happens when something happens? I don't know cookie clicker. But basically, it's a form of, you're making a game robot here. And in this case, what we're doing is we're injecting it into a website. So it's into an actual working and live system. Now, normally when you're building a robot for a game, you would actually use it as a plugin or as something which, reads inputs and gives outputs. But in this case, we're actually kind of hijacking the internal functions, and we're replacing them with fake ones. I don't think that's on a website. Cookie clicker, I don't know. I know the paperclip is on a website, so yes, you could hack that. You're basically overwriting what's in there. You could, for example, hack the Mozilla game, what is it? The jumping dinosaur game that Google Chrome has. So when their network is dead, you could write a script that just fixes that, and then record that and put it up online and just say, "Hey, look how good I am." Reach infinity in that, can you? I don't know. Anyway, so yeah, it's you can use this method for any online game, anything you can think of. Chess, for example, that's cheating though. Can we do it? Hack the dinosaur game? Yes, you can. Now, the problem with me making a live video demonstrating it is that the dinosaur game only happens when the network is down. So how would I do that? I would basically have to have a second computer and hook in the network for that, but it's tricky. Yes, we could do that. Or we could probably find the code for the dinosaur game and make it run online, so we can just run it when we want and then hack that. Might do that. Anyway, in the last class, I asked people to do a little bit of homework. Just do anything and just show me. So here's the bit where everyone just kind of says, "Oh, did anyone do anything?" I'm guessing the answer is no. That's fine. You've got better things to do. Places to go. Hope not. All right, hack the dinosaur game. Yeah, well, do you know what? That'd be an interesting thing if anyone can come up with that. Well, or maybe even see if you can find a way of getting the dinosaur code to run without it having to be offline. There's probably a way, probably an easy way. I don't know. Has anyone got any questions? So far we haven't been talking about philosophy, which I think is interesting. You made a rainbow generator in Scratch. Cool. Now, is there any way we can look at that? Do you have that a URL for it, or exactly what does it do? How do you inject the code? Right. Okay. To go back to almost the beginning, what I did was I had a look through the source code to see what happens when you press a button, and I followed the code until I found a point where I thought that's a place where I can kind of that after a button is pressed, this bit always runs. So that was in Game Manager. I looked through the code. Just close that. In Game Manager, I looked through the code and I found things like this: update the actuator. And I was following the functions to see what do they actually do. This.actuator.actuate. Update the actuator. So actuate. This.actuate. I found this function here, and I found that there were only 3 mentions of it. One is where it's actually being created, and then these 2 calls here where it's actually being called. So it's only ever called after the first move, or when the first move is made, or when somebody presses a button. And that's ideal because it's what I wanted. So I found the this.actuate function, which is it that? Yes. So it's this, and we're basically just hijacking it. We're making another function with the same name, And then we're just taking this one and naming it something different. And then when the fake one is called, it calls the original. So according to the game, nothing's changed. It's still working as normal. But we know now we have a man in the middle, which is our fake function. Okay, does that answer your question? That's basically what this line at the top is for. So we're saying that the real one is this game manager.prototype.actuate, and then we're overwriting the prototype.actuate with a fake one, which calls the old one. Right? So hopefully that answers the question. Now, how you would do this in something else, it's different. Like you might have to, at the worst case, in fact I tried this before I just bothered reading the code. At the worst case, what you could do is attach event listeners to key presses, and you could fake key presses, and you could just force key press events into the game. But that's insane level. You know, that's if you've run out of other ideas, then yeah, fake a key press. There are ways of doing that. I mean, at the worst, you could even make a robot that just presses the button. But no, there are ways of actually faking it with software. You could just trigger key press events. In that case, what you want to do is look through the code for to see what key press events do they actually look for. And it's not in this page. Nope. Keyboard input manager. So I looked at this page first because I thought maybe this is the way to do it. You see these numbers here. These actually correspond to the number codes of the letters that you press. So if I press a W, for example, then that's number 87. And the reason it's 87 is because these are actually the ASCII keys. No, they're not actually. Yes, they are. Capital A, 65. But the up, right, down, and left, they're not ASCII keys. Those are keyboard mappings. So when you press a button, it actually has a code. So the programs can figure out what you pressed. Because sometimes you press something like, you can't just say, if it's equal to left, well, what is left? How can you type left into a computer program? You can't. So you say, if the key that was pressed has the code 37, then that's a left. So, but what we can also do is we can fake that. And that's where these listeners come in. So it's adding, if you look at these codes, it's creating a function document.addEventListener keydown. We can trigger a keydown event. So that's a keydown is when you press the button, that's a key down. When you let go, that's a key up, but it's also a key press. There's a lot of different events that happen in a lot of things. Like even if you look at the top here, touch start, touch move, touch end, pointer down, pointer move, pointer up. There's also mouse down, mouse click, mouse up, mouse move, mouse enter. Lots and lots of different ways of checking for things. I'm probably overcomplicating things. Does that answer the question? You're all very quiet today. I'm going to run the program again. Whee! Think so. Okay. The best way to find out is just see if you can do it. In fact, see if you can replicate what I've done here, even just to the point where it will tell you that you've made a move. Just see if you can get it to respond to the fact that you've made a move. Or do it in any game. Like that's the start basically. The start, like you notice that when I'm writing this, I'm always using these console logs. And the reason for that is that you don't write the full script and then figure out, oh, why didn't it work? You write it in little bits. And when you write a little bit, you check to see, did this work? Because no matter how long you've been programming, and I've been programming a very, very long time, no matter how long you've been programming, you will make the simplest mistakes every time. It's always something very, very simple. So if you make a long program, I can guarantee you it is not going to work, no matter how good you are. Posted a link to the rainbow generator. Where did you post the link? How do you change the source code? Right, I'm not actually changing the source code. No, that's what I'm doing here, is I'm not changing the source code. Hold on, this thing is going mad. I'll just reload this. I'm not changing the source code. What I'm doing is I'm injecting new code using the console. So if I, for example, create a function, okay, so I've just created a function. Now that function is attached to this page until the page is reloaded. It's in the memory of it. So if I run, say, hello, then a pop-up appears saying hello. Now, this is not changing the existing source code in that page. I can't do that. But what I can do is I can rewrite it, which doesn't change the original source code. It rewrites what's there. But I don't want to rewrite the entire source code. What I want to do is inject something which just reacts to what happens on the page. So that's where the middle man in the middle comes in, because it's reacting to a move, saying like something has moved, let's look at the board and make another move. So I'm not changing the existing source code, I'm just adding to it. And you know, when you paste it into the control console, it runs within the page context. So it runs based on what's in the page. So, for example, if I just type in document here, see the way the entire screen went blue? It's because it's talking about that. That's the context, document. So we press enter on that, and let's have a look at that. That's the document. So it's talking about this. Now, if I type in window, this gets even more interesting. Press enter. Now we have everything, including the source code, that has been attached to this window. So we've got this window game manager, which is some JavaScript. Grid, HTML actuator, this is all the code that was attached. Alert, even all the the code that's built into the system, that's in there as well. And if we look further on down, there's the code I wrote, say hello. So we're not really changing the source code, but what we are doing is we're adding our own, which possibly might overwrite and add on or replace the existing source code, but we're not changing it. Amit, where did you post the link? Did you post it in that chat thing? If so, I think YouTube is probably ripping it out. You can email it to me. Email me, you know, my email address is k@verns.com or k.verns@gmail.com or k@kvsites or whatever. Lots and lots of different email addresses. If you just email me whatever cool stuff you've come up with, actually that's a cool idea. Email me whatever you come up with and I'll have a look at it and we can talk about it. We can talk about it next week and maybe we can do some cool stuff with it and maybe enhance it in different ways. So, I mean, obviously I don't do Scratch, but what I can do is replicate it in JavaScript and see what we can do here. So I'll just type in. All right. If you want to email me anything, just send it to that address and I'll have a look at it and we can talk about it. I'll reply to it if you want to keep it. Like, it doesn't even have to be something that you want to be publicized. If you don't want it to be in public, just say, look here, don't share this. And I can just give you my thoughts on it and, you know, we'll look at it. Anyway, so the project number 399544145. I don't use Scratch, so I'm going to guess at this. Do I go to the MIT website? I'm just going to click on any random one and change the number and see if that does it. 399544145. Hey, there we go. Okay, so this is Amit's rainbow generator. Let's have a look at that. Do I press this? Press space to begin if you want to check a setting. Let's just see what it does. Stop. Okay, I think I broke it. Let's reload that, try that again. That's pretty cool. Now, I'm guessing that what you've done here is you choose two colors and then you increment gradually between one value and another, because colors, the way colors work is that they are their values of red, green and blue. So my guess is that what you've done is divide two numbers, delete them, get the numbers, divide by how many cells you have, and increment one at a time. That's how I would do it. So let's see inside. Is that the source code? Let's have a look at that. Oh, here we go. I drag that. Right, let's see. Color change, blah blah blah, blah blah blah. I don't know what this does. 40 steps, right? Switch costume, color change, determination. So, press red thing to stop. Yep. Okay. Hide variable, color change determination. Right. Alright, so let's see. Show value, color change determination, show variable. Forever. Costume. I'm not sure exactly what is going on here. I don't see the bit where it changes things. I'm obviously change Y by -20, so that's moving when I start as a clone. So this is changing you're creating a cloned object and you're moving it. Okay, when I start as a clone, show forever. If goes on, then change Y. So that looks like it goes down. Right, change color effect by color. Right, okay, I see. You're not doing what I thought you were doing. Okay, so this color change determination, it looks like in Scratch you might be able to just add to a color a certain amount. Color change determination, it's a variable, so you're basically adding a number to the color. So my guess is that colors are just numbers that you're just adding to the number. Yeah, okay. All right, that's I like the idea of it. I like that. Let's go back and play that again. How do I go back? See project page. Yeah. So if I change this number, then I'm guessing the value of change would be smaller. Let's play that and see. Yes. Okay. Oh, I see. Yes. Oh, that's interesting. So I hit. Okay. Stop. All right. What does this do? Let's change that to 2 and see what it does. Change this back up to 1. That. I didn't have to press play, did I? Ooh. That's pretty cool. All right. And what if this is 1? I don't have to press play each time. That's silly of me. I see. Okay. That's cool. Now, what does type do? So you've got 1 or 0. Press space. Press space to begin. If you wish to change a setting, just click and change. Press space. Ooh. Alrighty. Okay, yeah, I see what's happening there. Alright, so in the first case with type 0, it's moving the screen, looks like, by Y once every like 20 or 30 pieces. But if it's 1, it's moving it every 1 clone. And then the determination, 3 would be always to the right, 2 would be alternating every 20 pieces or so, and 1 is always to the left. I like this. And the color change determination, it looks like the color itself is a value, and then when you add 1 or 10 or whatever to it, it just increments that value. But I'm guessing you don't have full control over the colors here. Tap space once, click to stop. Yeah, I like this. I really like this. Now, what would be really cool is if you could make it into an arc. Now, to do that, you need to know a little bit of trigonometry. Actually, you might not with Scratch. Scratch probably has tools that lets you do that. Can you do that? I wonder. So with trigonometry, you would do it based on the sine and cosine of the degrees that you want to do. So you want to go from, let's say, 0 to 306 or 180 with certain steps of, let's say, a step of every 30 degrees or so. And then you get the sine and cosine of those values, and then you multiply that by the radius of what you want, of how far out you want it to be, and that gives you the x and y coordinates. Play around with that. If you can, try play around with the sine and cosine, because you know it'll open a whole new world for you. You're going to discover a lot of things. In fact, if you get a kind of an intuitive feel of what sine and cosine do, then that leads you towards 3D graphics. You know, we could start talking about how do you do wireframes, 3D wireframes, for example, and I can demonstrate that in Canvas. I can do that, like I did a couple of years ago. We did a rotating cube in wireframes, totally from nothing. Then we started building it in Canvas in JavaScript until the point where we had a rotating 3D cube using proper optical stuff. Using the proper maths, trigonometry. Okay, so I think we've probably gone as far as we can. Nobody else has anything to show, no? That's fine. Okay. No, I like watching other people's work and trying to figure out how would I do it, how would I make it different. So what I'm suggesting for you, Amit, is that you look into how does sine and cosine work, and see how can you use that in Scratch to maybe make a rainbow that's actually an arc. Okay, so have a go at that and see if you can enhance it. All right, and we'll talk to you all next week or in 2 weeks. And I don't know what we're going to do. Maybe we'll do tower defense. Maybe we'll do this Chrome dinosaur game. Don't know. I mean, I keep coming up with ideas and I keep changing. So never know. Hopefully this was interesting. We got to an infinite score in an online game. Okay, so I'll see you all next time, or you'll all see me next time.